Okay, can you all hear me okay? Great. Thanks for coming and thanks for having me, ODSC. Thanks for the introduction. I hope the conference has been going well so far. It has for myself. I'm happy to be here. And again, this is a workshop that'll allow you to assess and choose a deep learning framework for neural network development in a deep learning centric manner. My name is Nick Acosta, and I'm a developer advocate with the IBM data science community. So I wanted to briefly mention that. The IBM data science community, you can find it at ibm.com/community/data science. It is a place to discuss your triumphs or your struggles or both or neither, anything about data science that you would like. Just if you have something that you're working on that you think others may be interested in, I think that this is a platform and an audience that I've had success in discussing some of my work, including this project that we'll be walking through today. So this is a workshop. If you would like to follow along on your laptop, that'll be totally fine. I'll be running every line of code on the workshop on my screen here. So, whether or not you have coding experience or Python experience or just don't feel like, hitting enter and clicking through cells in a Jupyter Notebook today, you can watch it on my screen. That'll be totally fine. But if you would like to follow along, I see we'll have, maybe I've been told by other presenters and by ODSC that the internet can be hit or miss here, so we'll maybe have this half of the room go ahead and pull down a repository. You can follow what I'm doing, and then we'll wait a couple seconds and then have this half of the room do the same thing. So everything that we'll need for this workshop will be in this repository. It's just a matter of, I'm going to be running everything from my desktop, and it is a matter of cloning that repository. Let's blow this up a little bit. Again, it's just git clone and unable to access, no. Let's try this one more time. Is anyone else that's following along getting the same thing? Let me unplug my screen here and try this to debug this without you guys looking. What is going on here? Step one would be connect to the Wi-Fi, which I haven't done. That's okay. I think I'm only going to use it for this very first second. Okay. Yeah. I may have to. It's saying service unavailable. Sure. Let me see. How's everyone doing? I think I'm online now. Okay. So that command one more time is git clone, and then it is a link to the repository for today. I think if you're on this half of the room, it would be okay for you to go ahead and do that now. So we'll be cloning a couple of different notebooks. Let's go back to that requirements prerequisites thing here. So if you have Jupyter installed, we'll be running Python 3. I think any version of Python 3 will be fine. We'll be running TensorFlow 2.0 code as well. If you do not use TensorFlow 2.0, it there are some instructions in the notebook to kind of update to the latest version or install it if you've never used TensorFlow. So that should be okay. And again, if these are things that you don't have, you can just watch my screen and I'll be walking through it for you. So the agenda for today, going through the introduction, again, I mentioned the IBM data science community. Before talking about some of the technologies, the prerequisites that you'll need, a Jupyter notebook, the ability to run Flask, things like that. We're currently on the agenda, and then I'll introduce the topic as far as that being able to choose a deep learning framework with deep learning. Part 2, we'll be discussing a data set that we'll be working with today. I'll give a quick introduction to deep learning frameworks, what they are, how they're used, and some examples of some. And we'll talk about how we can process that data and get it ready for some models. Before part 3, actually executing and training some models, we'll talk about a way we'll be dealing with text, so we'll give a quick introduction to text embeddings, what those are and how they're beneficial. For talking about some different model architectures, and then part 4, we'll be serving those models, building out a place where others could possibly use the models that we build today, before wrapping up and giving an introduction to an IBM project that I'd like to share. So as a developer advocate for IBM, especially in the data science community, a question that I'm often asked is, I often interface with developers that are maybe just trying to get started in deep learning. Is that anyone in the audience today? That maybe, yeah, so that's a familiar question that I get asked is I'm interested in getting started in deep learning. Which deep learning framework should I be using to start building out these neural networks, try to learn this field? It's not just a question that I'm asked. It's a pretty typical topic of content. You don't really have to search far to find different examples. But the content usually falls into 3 different camps. There can be, like this article here, a historical overview of kind of some different deep learning frameworks, how and why they came about. There can be an explanation of differences. This is what this author talked about in KD Nuggets, kind of describing PyTorch versus TensorFlow, maybe when to use one or the other. Or they can be an advisory of preference. This author at Udacity says PyTorch or TensorFlow or PyTorch, the force is strong with which one? All right, so there's a variety of different content on this subject. And a lot of the content is a combination of 3, but almost all have an advisory voice as far as kind of steering you to which one to select. But to me, for that is prone to subjectivity, maybe the author's point of view, author's experience, and anecdotal evidence. But most importantly, I think it's prone to the current state of deep learning frameworks. Like, for instance, this KD Nuggets article, if you can't read it in the back, he's saying PyTorch is better for rapid prototyping and research, for hobbyists, and for small-scale projects. TensorFlow is better for large-scale deployments, especially when cross-platform and embedded development is a consideration. Which I think both of those, if you're familiar with PyTorch and TensorFlow or both, I think that statement is becoming less and less true. If you're familiar with a lot of the things that are coming out with TensorFlow 2.0, it is assessing that rapid prototyping, that hobbyist point of view that he's saying is better for PyTorch. I think that's becoming less and less the case. And you're seeing PyTorch do the exact opposite, make strides to be more enterprisey, more cross-platformy, things like that. So, the field of deep learning is changing very rapidly, and the frameworks that support it are changing just as often. So it can be hard to take into consideration one of these articles and providing that advice. So my advice is to start with a framework chosen for you via deep learning, which is what we will be doing today. This way you can align yourself with maybe the problems that you're solving or the way that you write is in line with a community that's already present and available in, say, TensorFlow or something like that. So the goals for some of this workshop will be to find a a deep learning framework for you to use. Another goal we'll be doing nearly every step in a deep learning life cycle, processing data, building out models, saving a best model, serving a model, things like using it, giving it to others, things like that. And then we'll get some exposure to some new things in TensorFlow 2.0, which just got released generally available, I think maybe like a month or two ago. So yeah, looking forward to it. But to be able to select a framework via deep learning, we need some data to do so, right? So that's what we're going to be doing. Building out a deep learning project here to help us select deep learning frameworks. To take a half step back, I wanted to discuss what a deep learning framework is and why they're used. So basically, they allow for the easy construction of neural networks. So I have easy in blue there because it's like a very relative, I think, for me, term. I just mean it's easier, in my experience, and thousands of other developers to use a deep learning framework to build out a neural network than to not use one, right? The reason why it becomes easier is because it abstracts away the lowest level detail. So I don't have to keep track of every node, of every layer, of every weight in my neural network. It can do that for me. It can do things like standardized backpropagation and things like that, and do automatic differentiation, things that are great that I don't have to worry about in neural network development. It standardizes commonly used neural network concepts from components of a model, like a particular type of layer or a particular type of loss function, all the way up to entire models, right? So some famously used models, I can just load those all in with the weights pre-trained and use them for predictions. They also provide tooling for deployment on various hardware configurations, including GPUs, which has become a standard in modern deep learning development, is the use of GPUs. We won't be doing that today in this workshop, just because I wanted to keep the workshop, free and as only using open source technologies, and I didn't really know a way to do so with GPUs without keeping it free and open, right?
Isn't it that Google Code is offering GPUs for free?
That's Google, that's not open source though.
Right.
Yeah. So what we have here are some classes, and the question was, is there a Google Colab that offers free GPUs, which there is, and it offers free TPUs as well, and it is cool. So what we'll be discussing is we'll be building a neural network to differentiate between two different classes here, the first of which is TensorFlow. Is there anyone that's familiar in the audience with TensorFlow, maybe how it came about, what it's used for? So it was developed for Google, the Google Brain team around late 2015. So they had a large amount of compute resources, but the machine learning frameworks at the time weren't able to maybe leverage them in a distributed way, in an efficient way, and things like that. So that is why TensorFlow was built out. And since it has kind of turned into an entire community, if you can't see that screen in the back, where we are not just doing neural network development, but also things to deploy models with TensorFlow serving, things to load and pre-process data, which we'll see today. So an entire ecosystem that's become, polyglot. There's TensorFlow for TFJS, there's TensorFlow for Swift now, so really quite an extensive platform. So an example of someone using TensorFlow is they built out a Pokemon card generator where they fed in examples of Pokemon cards into a recurrent neural network and were able to produce their own unique AI-built Pokemon cards using TensorFlow and GANs and RNNs to do so. So that's just a case study and example of something that you can do with TensorFlow. Another deep learning framework that we'll be discussing today is PyTorch. That came out of Facebook via the Torch and Cafe2 communities around the same time, late 2016. And you're seeing a lot of similarities there, including a case study where this team built out Pokemon GAN, which took Pokemon sprites, which are not cards, but they're just pictures that are used in like the Game Boy games and things like that. And they fed them again to a GAN and were able to produce their own unique Pokemon. And as you can see here, I'll be sharing my slides, and these are all hyperlinked if you'd like to see the models that they built out, the PyTorch code that they used, things like that are all embedded in these slides. So you can see doing two very similar things, but doing so in very different ways as far as the architecture that they structured, the code that they wrote, digging through these two repositories, doing the same thing. And you can already start to see differences in very similar projects going about their work very different ways, because one is using TensorFlow, one's using PyTorch, right? So you can see there are some distinct lines that I think have already started to form in the 3 or 4 years since these deep learning frameworks got started, as far as what their communities are using these deep learning frameworks for, the way that they write, and things like that. So I've built a data set to address this. It's just crawling GitHub for repositories that mention TensorFlow and repositories that mention PyTorch, including the two examples that we saw earlier. And if I search GitHub, GitHub has a PyGitHub extension that I think is very helpful and beneficial to build out data sets like this. If I was searching for TensorFlow, I would recursively walk through those repositories, grab all of their Jupyter notebooks, label them as TensorFlow, and then store them in a data set that we'll be seeing today. Did the same thing for PyTorch. Waited a weekend, waited another weekend, and then we've got this data set. So some stats on this data set. It is a random example or sample of over 11,000 different notebooks that reference and use these two deep learning frameworks, collected from January 1st of this year through July 31st. The split ended up being 56% TensorFlow to 44% PyTorch, which as a TensorFlow developer, I thought that it would be a lot more heavily skewed in that direction, so that was interesting to see. These 11,475 notebooks come from 4,045 different repositories. There is over 6 million words used in this code, but only comprised of 45,785 unique words. Okay, so if you're following along, let's get through to that first notebook where we're going to be pulling this data set down and getting it ready for development. So we're going to download that example data set and prepare it for our neural networks. And we're going to be using a library through Keras, or TensorFlow's implementation of Keras, tf.keras.text.preprocessing. So let's see what that looks like. Again, all I did to get this notebook was clone this repository. I'm in Jupyter Notebooks. This is just running on my laptop, but I'm pretty certain if you use Google Colab or any other type of cloud service, private service that runs Jupyter, these notebooks should be fine. So in this clone repo, if we go to the data repository, there is a data.notebook. So we'll be importing some things, and then make sure that the TensorFlow that you're running is TensorFlow 2.0.0. If that's not what you have, you can just change the next cell from markdown to code and run it. It should be able to bump you up to TensorFlow 2.0.0. Then you would have to restart the notebook, run these first 2 slides again. But has anyone in the audience used TensorFlow 2.0 yet? Familiar with it? Good. I've been seeing in the schedule, I haven't been able to attend some of the sessions, but it looks like a lot of them that reference TensorFlow have been using TensorFlow 2.0, which is cool. So we will be downloading the data set, getting it into Python. And this is I think, the only other time I'll need the internet here. So this cell may take a second. But what we'll be doing is pulling that data set in, and then we'll take a look at one of the examples of a notebook that we saw. So here we see those 11,000 different examples. We're dealing with a data set that has 2 different columns in them. The first column would just be this code that you see here. The second column is going to be a label that I used to search for that code. So this one would be PyTorch. This came from a notebook that uses PyTorch. And you can see, if you read through the code for this example, it looks like they're trying to build a classifier that could differentiate between pictures of a cat and a dog. Which is great, and it looks like they may be doing some plotting of those images first, and then they're going to attempt to build a network to classify cats and dogs. So the next thing that we will do is strip all the references of maybe what we call stop words, things that would be like dead giveaways that really wouldn't be very AI-centric. If one of the notebooks had a reference to TF and our classifier ended up classifying it as TensorFlow, well, that's not very impressive. So let's remove any reference to TF or Tensor, or TensorFlow, or PyTorch, or those things. And then we will also, in this cell, be converting those codes to labels. So this is for use in our neural network. So if a code example is labeled PyTorch, it'll be given a 0. If a code example is given TensorFlow, it'll be labeled a 1. So here you can see that same example where the person is building out a cat versus dog classifier. Now it just changed the label. It removed all of those stop words. And now we're ready to process this data. So we're dealing with text here, and an easy way to be able to feed text into a neural network. We can't really give it anything that's not 0s and 1s really at the moment, right? So we're going to have to do some translation, some pre-processing to this text data set. To do so, we'll leverage the TensorFlow's Keras pre-processing library, and we're going to be specifically using that for text. And this builds out an index of all the words that are within my data set. And you can see here, as I mentioned, there's over 45,000 unique words in this data set. And we'll be able to translate this data set into one that just creates an index into this tokenizer. And we'll see what that example looks like here. So this is the same code that's now been pre-processed into something that our neural network can actually operate on and operate with. So if we look, it is now a vector that is 1,000 words long in length. So if we have a notebook example that's more than 1,000 words, we'll just kind of cut it off at the tail there. You can see most of them are not 1,000 words long, so it'll be padded with 0s in this manner. And to give you some information on kind of what this is doing, so the first number here is 100, which corresponds to the same code example. The first word is matplotlib. So if we look at our tokenizer and we index on the word matplotlib, it is the 100th word in our index. So it's just replacing that matplotlib with what it is in our index, which is 100. So the way that it's building out this index is just by which words are used most frequently. So matplotlib is the 100 most used word in this data set. So we can take a look at some of those here. Like train is the most used word. If you can't see in the back, let me blow this up a little bit. Train is the most used word in this data set. Data is the second, right? And if we scroll down far enough, we'll see matplotlib. All right, so just being able to pre-process data using these Keras libraries to get it from this code into some numbers that our neural network will be able to understand and process on. And then just saving that work. We've also split it into training and testing sets there, which I didn't show, but just doing, I think, like an 80-20 type of split, things like that, and then saving those for another notebook that I'll be showing shortly. Does anyone have any questions on that first notebook? Has anyone been running it by themselves and seen similar things? Yes. I think, yeah, you made, I don't know really how to help with a memory error. I'm sorry. Maybe instead of, the only thing I can think of is to maybe just close it out and rerun it again. But yeah, we are dealing with quite a large data set here, so could be some issues there, unfortunately. Okay, so to perform deep learning on this data set, we're going to need some models, right? So that'll be the next part of the workshop is a modelist notebook. So we can check that out now. So what we'll need if you're following along we won't be able to load in that. We're going to try to load in these we saved the data set in the last cell of the last notebook. We're just going to try to load that back into this notebook. And to do so, it's saying, it hasn't found, so we're going to have to, that's just because it's in a different directory. So we'll have to move it. So if you just run this command where we're moving it from the old repository into this current working directory, it should be able to work. Yeah, I can make it bigger. Yeah, so if you didn't catch that command, we're moving everything with a NumPy extension into this current working directory that we're in so that we can build some models with this data. So we have in the next cell neural network using TensorFlow 2.0's implementation of Keras. So what we'll be doing here, and let me get this running and then I'll explain it in a second. Or actually, yeah, I can explain it now. So we're going to be using an embedding layer through tf.keras.layers. And what happens with text that we saw here in the previous example is that it can be pretty sparse, right? So we have room for these notebooks to have 1,000 words. And it can often be the case that most of them are going to be padded with a lot of zeros. This leads to a really sparse data set that your network can have trouble with. It'll increase the amount of training time. It will make your gradient descent kind of wonky in some cases. It's just not good. So we can translate our sparse vector space into a smaller but more dense embedding space using this embedding layer. So what we'll be doing is translating this space into one that is over 45,000 different columns in length, into one that's only 1,000 long. So decreasing it by a factor of a couple thousand, right? Or decreasing it by a factor of 45, I'm sorry. That'll make our vectors more sparse. That will make our training go faster. That will make our gradients go in the right direction without doing things like vanishing gradients that can happen in sparse data sets. But what we can see here, there's still a small issue if you're running the cell on your own. I'm only training these for 3 different epochs, going through the data set 3 times, and we can see that it's going to take over 9 minutes to be able to run this training time, which for our 90-minute workshop is too long, right? We don't want to do that. So luckily, there's something a lot easier that we can do. And that is to just rebuild a tokenizer that we did in the last data set, right, where we saw we were building an index that was using every word that's available within our data set, 45,000 different words. All of them gets an index in our tokenizer. What you see in this data set that we're working with today, and every data set, is, again, they're sparse. There's a lot of words that are used very infrequently. So if you go back to those examples where people are building out Pokemon generators, there are a lot of words that they're going to be using, like Pokemon, that no one else is going to use, right, that are not very helpful in our classification of what makes these deep learning frameworks unique. So we can just strip out very infrequently used words like Pokemon and others. And now we'll be using a tokenizer that only uses half of the half most frequently seen words. Anything other than that is probably only seen once or maybe twice and really won't help in our classification. So now we're just going to build out that same model, only using this new tokenizer that only takes into consideration the top 50% of the most used words within this data set. And now if we start running that same network, instead of it taking 9 minutes, it's going to take 90 seconds to go through one iteration of this data set. So what I wanted to show on this slide, let me blow this up a little bit bigger, is a visualization showing what I just discussed. As far as using like every word in my data set versus using maybe only the most frequently occurred words, and how that can affect training and things like that. So here we can see a picture where if I use 100% of every word that's within my data set, it makes up 100% of the total words seen in my data set, right? And that makes sense. And then after I train it for going through, if I would have let it run for that whole 9 minutes, after one session through my data set, it has an accuracy of 85%. But if I use, we can see here, if I use just 80% of my data set, it's still encompassing almost 100% of my data set. So if I chop off the bottom 20% of the least frequently used words, those are almost never occurring, right? And even if I only use the first 1% of the, one out of only the 1% most occurring words within my data set, I can still see that that is almost 80% of my entire data set. If I use only 1/10 of 1% of my data set, only the 40 most frequently used words when programming using TensorFlow or using PyTorch, it makes up 40% of the total words. And it doesn't really affect the accuracy of my models, right? But you can imagine that the training time becomes much, much quicker. So this is something that we see in this data set. It's something that you see across different text data sets. If you look up Zipf's law, it occurs pretty much everywhere where, if I have a body of text that's big enough, the is going to be the most frequently used word. Then the next most frequently used word is maybe like I, or I think, or something like that, and it occurs half as frequently as the, things like that. And it always follows this kind of an exponential curve that we see here. More on that embeddings layer that we used. Again, just to reemphasize, it translates a data set from that low dimensional, very sparse data set into something that has less dimensions but is more dense. So if I'm using that for a neural network, it decreases the number of parameters but increases the number of high parameters, and that's a trade-off that in this instance we like because it decreases the training time. I just have less parameters to train, I can do it faster. So there are common predefined text embeddings. If you've heard of word-to-vec, that is, I think, the most popular one. But those aren't, it wasn't really appropriate to use that. You can, like TensorFlow's Keras library has word-to-vec in it. You can just load that in directly. It wasn't really appropriate to use because that's based on like English. I think it's based on like literature, I think, or something like that. And that is very different than how people write code. And it defines semantics. So if, like, I think the position of where, like, boy and girl, I think, are really close together in word-to-vec, and it, like, matters how close you are to a word. That means that, like, you're more similar to that word, which is kind of nonsensical in a coding universe. So you can either use common pre-trained text embeddings and load them in via Keras, via TensorFlow, or you can train them. As we saw, it can just be a layer within your neural network that you train. It also enables text CNNs, which is something that we'll see here, which is pretty cool. That was coming out of, I think, NYU in 2017, where it was, if you use an embedding layer, you can kind of translate your data set to a space where you can run some of the very popular and very successful and very accurate CNNs that are used for image classification can be used for text classification if you just add an embedding layer before them. And then all you have to do is translate it from change convolutional, when we're doing image classification, it's two-dimensional convolutional networks because you have write a length and a width to an image to a one-dimensional convolutional network. And then you can see this one, I just mirrored the exact architecture for LayNet, which is a popular image classification model. And you can use it directly, this time for text classification. So we can take a look at the first model that I had trained. It's finished training. We've gone through 3 iterations of the data set, and we're able to build out a pretty accurate model. I don't know if, yes? Versus the, Oh, okay, sure. So he asked, what is the difference between using Word2Vec embedding versus an embedding layer in Keras? So you can load in Word2Vec or other common embeddings into your data set or into your neural network, or you can have Keras train an embedding layer itself. So that's what we're doing here. We're just having it train its own version of like Word2Vec, say. So there's kind of two different options for using text embeddings. Something that someone else has already built out for you, or you can have Keras build one out itself, where we're just mapping that all of our entire vocabulary into that higher or lower dimensional space. And it'll like just train the best way to do so. So is anyone that's following along on their laptops getting these models trained? Any issues? That's good to hear. So what we'll see these last two lines that are new to, or I guess at least different in TensorFlow 2.0, is we'll be able to save this model. And the model ends up being quite large, so I'm just saving it to a temporary file that'll go away next time you turn on your laptop. But we'll be saving this model using savedmodel.save, and then we'll be saving that tokenizer that we used as well. Oh, thank you. All right, so let's take a look at that actual notebook. What we'll be using after we train these models is we'll be saving them as well. So an easy way to do that is with TensorFlow.savedModel.save, which has been renamed from TensorFlow.saveModel.simply-save in previous versions. So, and then we'll be saving that tokenizer that we built out as well. So we'll be able to load it back in and be able to use that for predictions. So if you're trying it out on your own, I've left some cells to where you can build out your own neural network model architecture, see how well they do on this data set, have at it as far as training on your own. But we're getting pretty close to about as accurate as possible. We're seeing some accuracy on our training data set that's over 95%, on our validation set that's hovering around 92. I think we'll see probably both of those increase here with this next model that again is just built out to mirror LayNet, which is an image classifier. Does anyone have any questions again on text embedding or TensorFlow 2.0 or what we're doing with those models, things like that? Yes. Yeah, no. So the question was if you want to use TensorFlow 2.0, do you have to use a GPU? No. There's no stipulations as far as hardware. I'm not using a GPU right now, which is why this is taking a minute to train. Yeah, it's not necessary. And actually not possible with the TensorFlow that I used. There's a different version that you have to install to use a GPU. So. Yeah, so I'm using TensorFlow 2.0.0, which is new as of, I think, about a month or two. Okay, so we'll let that, for those that are following along, your model should be probably somewhere in this stage of training. It looks like mine will be wrapping up here soon. And again, all I'm going to be doing is saving that model. And we can talk about a little bit more about what it's saving and how to use that here in this next section, which would be model serving. So this is something that I think has become more and more popular, which has been cool, great for me to see it in like data science communities. I feel like we've kind of evolved from being able to figure out, placing importance on more and more accurate models and maybe how important that is, into how do I get people using my models, how do I make sure that they're fair, and things like that, where we've seen, in schedules like the one here at ODSC, I think reflect that, right, where I haven't noticed people really talking about how accurate their models are. It's more about, is it consumable, is it fair, is it interpretable, things like that, which is really cool to see. And there's a number of different ways that we can serve and make this model consumable. What we'll be using today is saved model, that TensorFlow saved model library in Flask is in this workshop. So Flask is a way to do web serving with Python. The reason why I'm doing it for this workshop, that method, is because I think it's smart to, in workshops, really keep them to one programming language, which we'll be doing here using Python. I didn't want to use Python and JavaScript to maybe serve this model in a web app. Although I'm seeing that is probably the most used and most kind of powerful combination, one that my colleagues use often at IBM and one that I'm seeing other programmers use in their applications, right? Build a model in Python with TensorFlow, serve that model in JavaScript with tf.js. I'm really seeing that used quite more and more frequently, and it tends to be working for those that do. You can also use TensorFlow Lite, things like that, TensorFlow serving. Or an option that I don't want to spend too much time on, keeping everything open source, but IBM does have a service called Watson Machine Learning that allows you to easily serve models. It'll just collapse your model into an API endpoint that you can give to a web developer or what have you to consume. And I'm sure other cloud providers have similar services. So this function that we'll be using, this TensorFlow.save, is replacing simple save, right? But what we're going to be doing here is saving the entire model, which makes it code agnostic, right? So I can save this model in Python and then bring it back up in JavaScript, things like that. I'm saving the entire model versus just checkpointing it. Checkpointing is another common way. Checkpointing will just freeze all the values of all the weights in your neural network, and then you can just load back in that checkpoint and either maybe keep training or use it for predictions or something like that. But you have to know exactly what your neural network architecture looks like, what the names of the layers are, things like that. And all of that concern becomes alleviated if you can just save and load in entire models, which is what we're doing. Using it with text, you'll see that we had to do something that was a little bit not TensorFlow centric here, where I am using Pickle to save that tokenizer, which is doesn't feel very clean to me because there is no functionality to bring in a tokenizer that I'm using from Keras. If I look at this, or if I look at my So if I look at the path here of things that are available to me, I can save something in TensorFlow 2.0. I can save my tokenizer here. I can just push it to a JSON, which is awesome. But there's no way for me to get like from JSON is not available, which is really odd. But it's a problem that's solved in TensorFlow 2.1. So if you're feeling comfortable with downloading that, it's already available if you just do like pip install TensorFlow nightly or something like that. You'll be able to do the same thing without having to use Pickle, which I think is better. So let's take a look at that. No, Siri. Let's take a look at this serving, what all is involved here. I said that we'll be using a Flask application to serve this model, so we can take a look at what we'll be serving and things like that. So we can look at the runtime. Yeah, we'll be using Python 3.6.7. Nothing really too cool about that. If we look at the requirements, all we'll need, again, is that TensorFlow 2.0.0 and Flask. This is super, super lightweight, so when I show this web application, don't laugh because I'm not good at web development. But, and then we have that, we have this tokenizer here that will be able to translate any notebook that I feed it into something for our neural network. And then we can look at, my screen is kind of too big here. We can look at what this Flask application is doing. So I'm going to be building out a website where I can just load in a notebook. It'll strip that notebook for the code, and then it'll send it to our classifier. So that's what this parse notebook is doing. It takes in a notebook file, looks for all of the cells that are of type code, and it will return all the code available. And then I will be loading in that tokenizer, again, that's translating, indexing every word in our code to something that Keras can understand. And I'll be doing the same thing, like padding it out with zeros, bringing in that saved model that you can see here, and then just using it to infer. And then saying the same thing if it's a 1 or close to it, I'm going to be classifying it as TensorFlow, or else it'll be PyTorch. Is there anything else to show? Yeah, and we can just get this started by running that file that I just showed. So here it is giving me the URL. Right where I just have this simple Flask application, and we'll be taking a look at, I'll be loading up a test example, just a notebook that says this is a test. I'll upload this, it'll grab just this code, send it to our classifier, and we can see what happens. Right, and it'll just spit back. You can try this on your own with your own examples of notebooks. And I think it would be more interesting than just feeding it this as a text, right? But it'll give you back that classifier that we just built and saved. It loads it into that Flask application, sends it, and then sends back your prediction. When you're done with that, make sure that you find, if you're doing this on your own, and you just quit that process, it'll still be running. So make sure that you kill, or force kill with -9 that Python process, which all I'm doing there is finding my running services right, taking this PID and killing it so that that port frees back up. But that's, taking that data set, which, is available on that GitHub, being able to pre-process it, get it ready for TensorFlow 2.0, build out some models, maybe save the best one, and then port that over to a web application to where I can have others use it. And you can kind of try that out yourself. Maybe if you have other code examples that you've been working on, you can classify them as, do I really belong in the TensorFlow community? Do I belong in the PyTorch community? Things like that. Has anyone that's been following along gotten that Flask application up? Excellent. Good to hear. Yeah, sorry, if you don't have that port available, it should be pretty easy to find and change around, things like that. I wanted to end the workshop here talking about a project at IBM that I'm really passionate about, that I think is really interesting, called Code and Response. So we have two different websites here that I wanted to link to, callforcode.org and codeandresponse.org. So our goal is to challenge developers to build technologies to aid in natural disaster preparedness and relief. And the mission through these two projects is to enable developers to deploy these solutions that they come up with resources, as far as like money and free cloud resources, things like that, partnerships, and through open source. So it involves coding challenges, which is what Call for Code is. It's an annual programming challenge that just wrapped up its second year. In mid-October, there was a development team out of Barcelona that was able to build a wearable that could track firefighters' health status as they are responding to danger, and kind of monitor where they're at, how they're doing, things like that. That team, again, out of Barcelona, won, I think, $250,000. And we've also, they've been working with resources both inside and outside IBM to go ahead and get that project. We don't want to just identify these solutions that could maybe help others and send them off. We've really been working through Code and Response to get these solutions in the field, get them tested by those who would benefit from it, and things like that. And then also open source this, all of this as well. So one of our program affiliates for Call for Code is the Linux Foundation. So we're seeing a number of different projects that are being maintained wholly, that are started through this Call for Code process, that are maintained now by the Linux Foundation, which I think is great to hear. And yeah, we're lending our partnership ecosystem. Like, I know not this year's winner, but last year's winner has been working with last year's winner were some developers out of Puerto Rico that were able to build. They were experiencing some flooding 2 years ago. Not some flooding, heavy flooding, right? That brought down all Wi-Fi communication, so they were able to build a mesh network that stands up a Wi-Fi and emergency network in the presence of floods. And we've gotten them to work with local governments in Puerto Rico, work with universities in Puerto Rico, things like that. So that, I think, is well on its way to being used, I think, by that territory, Puerto Rico. So I'm happy to see that. And again, that was for Call for Code, so they also won that $250,000 cash prize, things like that. So we'll be starting that up again in March, if that's something that you're interested in, if you have an idea that you think could be a good candidate. Again, the focus has been on disaster preparedness and relief, but our broad mission is to just help those going through adversity. So hopefully we can continue to do that, but it'd be great to get some ideas and some support. But that's all I have for today. We can end a couple minutes early. Thanks for coming. Thanks for coming to ODSC and coming to my talk. If you have any questions, I can stay, or I will be at 1:30 to 2. I'll be in Alsace for a Meet the Speaker session. So I'd be happy to talk about Code and Response, talk about this project, IBM, TensorFlow, anything that you may have questions on, either right now or again at 1:30. Any questions right now, or I think we're good. Thank you. Thanks for coming.